So now we're going to further explore the ideas of these ratios within triangles, and we call these the trigonometric ratios. I know it's a pretty big word. The trigonometric ratios basically come from the idea that all right triangles that have the same angle measures are similar. And we all know that that's true. All 45, 45, 90 triangles are similar. All 30, 60, 90 triangles are similar because if two figures have the same angle measures, then they have to be similar. And we know that these ratios hold true no matter how big or small the triangle is. We learned that in the previous video. And a lot of what I'm going to be saying in this video comes from what we talked about in class on Wednesday and Thursday. So if you want to pause this video and wait until after you've been to class on Wednesday or Thursday, then you can. So we're going to be talking about these buttons on your calculator that are our trigonometric ratios. Those are sine, cosine, and tangent buttons. Now, you've always probably thought of them as sin, cos, and tan. What these buttons are is they have all of those ratios stored for all of the acute angle measures in a right triangle that could ever exist. So, that means that whether the two angle measures in the right triangle are 0.01 and 89.9, your calculator knows the ratios between the sides. But in order to tell you what those ratios are, your calculator has to have you be smarter than it and have a way to let it know which sides you're talking about. So this is what we call the idea of having a reference angle. All right? A reference angle basically tells your calculator what the angle measure of your triangle is. And when you tell your calculator what the angle measure of the triangle is, then your calculator can immediately start pulling those ratios out of its memory. But your calculator has to know which sides you're talking about. Are you talking about the one standing straight up? Are you talking about the one laying down? Or are you talking about the hypotenuse? Okay, your calculator can't read your mind, so we have names for all three of the sides of a triangle. We call these three sides the hypotenuse, the opposite side, and the adjacent side. And you have to be able to name these sides based on that reference angle that you're going to tell the calculator. The hypotenuse is really easy. We all know where the hypotenuse is. The hypotenuse is the side that is across from the 90-degree angle. So in the 45, 45, 90 triangle at the bottom, this side is the hypotenuse. Okay? Now, the other two are a little bit trickier, but you should be okay. Opposite side is the side that is across or opposite from the reference angle. That would be the side that it doesn't touch. So, the side over here is the opposite side. That means that the side that touches the angle, see how it touches it? It helps make up the angle. That is the adjacent side. We know that adjacent means beside, so that'll be a way for you to remember it. But if you can name the hypotenuse and the opposite side, then you know that the third side has to be the adjacent side. So what you're going to be telling your calculator is, hey, I've got a 45, 45, 90 degree angle or triangle, and I want to know what the ratio is of the opposite over the hypotenuse in a 45, 45, 90 triangle. Your calculator recognizes the sine ratio as being the opposite over the hypotenuse, the cosine ratio as being the adjacent over the hypotenuse, and the tangent ratio as being the opposite over the adjacent. So in your calculator, if you put sine 45, it'll look like this. Your calculator automatically knows that you're asking for the ratio of the opposite over the hypotenuse. Now, it's going to give you a decimal. So let's look at our opposite over hypotenuse. In the 45 degree angle, reference angle, our opposite side is 4, and our hypotenuse is 4 square root 2. So in the calculator, I am going to divide 4 divided by 4 square root 2. I have to put 4 square root 2 in parentheses. So 4 square root 2. And I'm going to get 0.707. Then if I actually do this idea of putting sine 45, put in sine and then 45, I get the exact same answer, 0.707, because your calculator knows that the opposite over the hypotenuse of any triangle that has this 45-degree angle is 0.707. For cosine, it does the adjacent over the hypotenuse. So for cosine of 45, we know that that's 4 over 4 square root 2. I'm going to get the same answers. If I put cosine 45, type it into the calculator, I get the same 0.707. Same thing if I do 4 divided by 4 square root 2. Tangent of 45, when you tell your calculator the tangent of 45, if you type it in, it's going to tell you 1. Look at what 4 divided by 4 is. The opposite side over the adjacent side is 4 divided by 4, which is 1. The opposite over the adjacent. Tangent 45 in your calculator is 1 because you just told your calculator, I got a 45-degree angle here in a right triangle. What is the ratio of the opposite over the adjacent? It is always going to be 1, no matter how big or how small that triangle is. So here's one more example. We've got a triangle with a degree measure of 53.13, and we know that the sine of 53.13 is asking for the opposite and the hypotenuse. So equals opposite over hypotenuse, 4 over 5. So sine of 53.13 in my calculator is 0.799, repeating. 4 divided by 5 is 0.8. Very, very close. That's a rounding thing. All right, your calculator is going to be a teeny tiny bit off when you're rounding. Now for cosine of 53.13, again, you're telling your calculator, I've got this reference angle. What is the ratio of the adjacent over the hypotenuse? In this case, we know our adjacent is 3, our hypotenuse is 5. 3 divided by 5 gives me 0.6. Cosine of 53.13, 0.600, and then eventually it goes out to a 1. But it's the same thing. Your calculator is smart. It has all of these stored in it. Now, we end up using these to solve for missing sides of right triangles. So here you have a reference angle of 50, and we need to find, we'll start off just finding one. This is the opposite side. We're given the hypotenuse, and we don't really need the adjacent. But if we can figure out what the sine ratio is of 50 degrees, then we can figure out what this side length is, because the sine of 50 has to be equal to whatever that side length is, that m, divided by 10. All right? So this is using what we did, except this time we don't have one of the side lengths. We simply cross multiply. We write sine 50 over 1 and cross multiply. M times 1 is m. 10 times sine 50 is 10 sine 50. And you put that into your calculator. 10 sine 50 equals 7.67. And that's your answer. So try a couple of questions on here and see if you can figure them out, and we will work more with this in class.